This is concept 47, circles and arcs. In this question number 1, we're asked to find the circumference of the circle and leave our answer in terms of pi. The radius is 4.9. One way to find the circumference is just to take the diameter times pi. The radius, the diameter is 4.9. Since they gave us a diameter, we're pretty much done here. It's 4.9 pi, and then we have centimeters for our units. That's it for number 1. Number 2 is a related problem, same concept here. We've got the circumference is given as 68 pi centimeters. We're asked to find 3 things: a diameter, a radius, and an arc length. Well, if we work backwards a little bit, if the circumference is 68 pi and circumference equals diameter times pi, then the diameter must be 68. We know that the radius is half the diameter, so that would give us 34. And the one we really have to do our work on here is the arc length. We know that the arc length is just a fractional part of the circumference, and in this case, it's the 80 degrees out of 360 fractional part. So 80 degrees out of 360 times the whole circumference will give us the fractional part of the circumference. That turns out to be 47.5 centimeters. Any questions on 1 and 2? Okay, concept 48, areas of circles, sectors, segments, and chords. And number 3, we're supposed to find the area of the circle and leave our answer in terms of pi. We should know the area is pi times the radius squared. The radius on this is 3.3. It's half the diameter that's given. So if we take 3.3 and square it, we get 10.89. And then times pi, and we're in square meters. That's number 3. On number 4, we're finding the area of the sector that's given. It's 130 degrees of the entire circle, so that's 130 degrees of the entire 360 degrees. And to find area of a circle, again, it's pi r squared. The radius is 8, so if we square that, we get 64 times pi is equal to approximately 72.6 square inches. Any questions on 3 or 4? Concept 49, geometric probability. This question says, what's the probability that a point chosen at random on the grid is in an unshaded region? Well, if we count across, we see this is an 8 by 8 grid. So there are 64 squares that a point could be chosen from. And it turns out that there are 24 shaded ones. I counted those because there's fewer of those, so they're quicker to count. 24 shaded ones, which would leave me 40 unshaded ones. I want to land in one of these 40 unshaded ones. 40 over 64 is 5/8. Which is approximately, well, not approximately, but exactly 0.625, or about 63%. Any questions on number 5? Number 6, we need to find the lateral and surface areas of the prism. If you recall, we can find the lateral area quickly by finding the perimeter of the base and multiplying by the height. Well, the base is a 6, 8, 10 triangle. So I've got 18 plus 6, or a perimeter of 24, times the height of 30. That should give me 720 square meters for my lateral area. To get my surface area, all I need to do is add in the areas of the 2 bases here. So that's 2 triangles that are 6 by 8. If I actually flip, I've got one 6 by 8 triangle. If I take the other triangle from the other end and turn it and stick it on this way, I've got another 6 by 8 triangle. There's 6 by 8. So that makes one rectangle. 6 by 8 is 48. So 48 plus 720 would be 768 square meters for the surface area. So I've got my 2 solutions here for lateral area and surface area. Any questions on number 6? Okay, number 7. We've got to find the surface area of a cylinder. We've got to leave our answer in terms of pi. Surface area is just going to be my lateral area plus the area of my bases. My lateral area, just like on the previous problem, is the perimeter of the base times the height. This base happens to be a circle, so the perimeter is just going to be circumference. And we know that the circumference of a circle is diameter, which is 9 times pi. So 9 times pi times 17 will give me all the lateral area. And I just need to add in the two circles on the top and the bottom. The area of those would be pi r squared. If the diameter is 9, the radius is 4.5. Square that times pi. If I throw this in a calculator, I get 193.5 pi square centimeters. Number 8, we're doing the surface area of a pyramid to the nearest whole number. In this case, I see basically two basic shapes. I've got a square on the bottom. The surface area of the square is pretty easy. 5 by 5 is 25. Plus, I've got these 4 congruent triangles on the sides that have a base of 5 and a height of 10. Well, I know the area of a triangle is 1/2 times the base times the height. So I can go ahead and plug that in and see what we've got here. Half of 10 is 5 times 5 is 25. 4 25s is 100 plus another 25 is 125. And this is square feet. Any questions on these last two problems? All right. On number 9, we're asked to find the surface area of a cone in terms of pi. We know that the surface area of a cone can be found by using the formula pi r squared plus pi r L, where r is the radius and L is the slant height. So it's a matter of just substituting in values. R is 5, so pi times 5 squared plus pi times 5 times L, slant height is 13. Calculating that out, we get 90 pi square centimeters. Any questions on number 9? Okay, number 10, we're asked to find the volume of a given prism. Round to the nearest tenth if necessary. I notice this prism has triangular bases, and I know to find the volume I need to take that area of the base times the height. Well, I'm looking at this triangle. It's 13 by 13 by 13, so it's an equilateral and or equal angular triangle. If I look at just half of it here so I can find the height, I've got 13, I've got 6.5, half of the 13, and then I've got to find the altitude here so I know the height of my triangle so I can calculate its area. Well, I knew it was equal angular from before because it's 13 by 13 by 13, which means these angles started out all being 60. And the angle that I just cut in half at the top is 30. So I got a 30, 60, 90, which means my sides are in a ratio of 1, 2, and root 3. So this side is going to be 6.5 root 3 long. That's going to be the height of my triangle. So the area of my triangle is going to be 1/2 times the base, which is 13. That's the base of the whole triangle, times the height, which is 6.5 root 3. And then the volume includes the height of the shape, which is the distance between the bases, or 27. So if I go ahead and multiply that out, what I get is about 1,975.8 cubic yards. Any questions here? Okay, the last problem on this exam asks us to find the volume of a cylinder. Again, volume is just area of the base times the height. The area of the base is the area of the circle, which would be pi r squared. R is 7, so r squared is 49 pi times the height, which is 14. So 49 pi times 14 is 686 pi. They asked us to leave it in terms of pi, cubic inches. And that's it. Any questions here?